In the past years, we've seen a lot of talks about how to hack devices that allow us to authorize access to a building. We've seen lockpicking, we've seen how to break into RFID doors, but we haven't seen how to break into intercom devices. And Sebastian, here today, will tell us more about that. He's a security researcher, and he's really interested into radio. So give him a big warm round of applause.
Thank you very much, and thank you for attending this presentation. So we talk about intercom hacking, but let's start about me. I'm working for the Synactive company. I'm interested in radio communication systems like Wi-Fi, RFID, GSM, PSC, and so on. Here at Synactive, we're doing red team tests. Red team test includes spear phishing, remote and physical intrusions. And speaking about physical intrusion, why we introduced into a building, it's to plug a malicious device or to dump computer memory, or also to let a malicious USB keys into the building to be less suspicious. But the main problem when we want to enter to a building is we always need a way to enter to this building. So how to do it? We know lockpicking tricks, we know RF attacks, we know social engineering can be also helpful, but what about intercoms? Routine tests with these precedent tricks works sometimes, but sometimes we get spotted. And intercoms could be very interesting because if we want to not be spotted every time and want to enter to a building at night, what we want is to enter to a building like a ninja. So we can maybe hack this kind of system to enter to this building. Also, intercoms can be, we will see that intercoms can be used to spy on conversation in the street. We see that we can make money out of it. It's a bit strange, but you see it's very fun. And also have a lot of fun with this kind of device. Also, I should warn you that this talk is applied on practical attacks on intercoms. But it also includes other devices which use the same system, the same techniques as new intercoms use today. So intercoms today provides a lot of features. You have passcode, RF tag access. You can also call a resident to open the door. But nowadays, we can see that a resident can be called on his mobile phone, and when he is called on his mobile phone, the intercom is using a mobile prefix to call the resident. That means that the intercoms is using the mobile network to call the resident. So, by curiosity, we were asking about would it be possible to play with this kind of intercom, with this kind of device? So we tried to directly call the intercom, but nothing happened. After that, I thought about maybe we can dump and modify the flash, but just imagine that we have to do it in front of others in the street. It's not ninja things. Or we can use mobile attacks because the intercom is using the mobile network. And so I will present now the intercom, dual phone, house intercom. Call it as you want. It's a voice communication device within a building. The term numeric refers to intercom that use the mobile network for our case. So they use a SIM card. And it allows to call a resident to open the door. And different types of intercom exist. You have conventional, simplified, numeric. The main difference, just look at the right, is that the numeric don't need a wire for each resident. The main difference is that it only use 2 wires for power, 2 others for the dual system, and after that, no wires for each resident. And that's why they are used because it avoids complicated and cumbersome cables. And wires can be replaced by GSM, 3G, 4G, or Wi-Fi. For our case, we will only focus on the GSM, 3G, and 4G. The simplified architecture of the numeric intercom, there are two. This is the first. The first, as you can see in this architecture, the intercom is connected to the mobile network through the BTS. And if a visitor wants to open the door, he calls the resident using the intercom calls the resident on his phone. After that, the resident answers to the call and open the door, and the visitor can enter. Another architecture is it's quite similar to the precedent, but the only difference is that if we want to manage the intercom, we use a centralized server, because in the previous case, if the residents want to manage the intercom, he only use his phone, send a command, and send a command to modify or add a resident to the intercom. But here, in that architecture, the one administrator can use a website, for example, to add or manage the intercom. So that's the main difference with the simple intercom and the intercom that use the M2M machine-to-machine architecture. In France, we have 5 brands that are very well known. It's like Comelite, Intrator, Noalc, and Euromed Captive. They cost a lot of money. It begins with 2,000 €, and after that, more buttons, more button you can ship, more it costs. For our first case, we choose the Lincom IDP GSM, which is also commonly used in private residence in Paris. So we will focus just in the first time we will focus at Lincom. But after that, during this presentation, we will also focus on the 3G intercom, which is used in a lot of buildings today. So also, I talk about the numeric intercom, but how to recognize it. Maybe spotting a nice LCD screen or a new steel case, but sometimes you can get very lucky and see that there's a 3G module, which is sometimes outdoor or indoor. And this 3G module has like 3 or 4 LEDs indicating the level, the quality of the reception of the mobile network. So with that thing, we can see that it's maybe using the mobile network, and it's likely it's good to know, because maybe we can do some attacks on it. Also, why I'm doing this presentation? Because mainly publications about intercom are nearly non-existent, but as we know, they use the mobile network to communicate with the residents and to allow the resident to open the door. So that's why we can, for example, use the previous publication on GSM, 3G, and 4G, and also the tools that are very affordable today. For example, the Blade RF that costs only 370 €, and the software is free. You can get OpenBTS for free, YetBTS for free, and start your own ROG base station, as you probably know. So with that tools, we are able to build our ROG base station, our GSM and GPRS ROG base station. And an interesting fact is that GSM and GPRS, you have a weakness. The weakness, as you probably know, is because there is no mutual authentication between the mobile and the network, the mobile network. So only the network is aware about if the mobile phone is legit or not, but the mobile phone is not able to check if the mobile network is a legit one or a ROG base station. Also, another good thing is the handover for an attacker, because stronger the signal is with the rogue base station, and much likely we are able to trap the mobile, the intercom, into our base station. So, for an example, if the mobile phone is always looking for the strongest signal, so if a mobile phone sees that one base station is sending a stronger signal than the older one, it goes directly to the new base station. So to summarize, there's no mutual notification in GSM, GPRS. We can also use a lot of attacks on FA1, etc. The signal channel is not encrypted. So interception is possible in GSM, in GPRS. But to overcome to that, 3G and 4G are more secure because they use mutual authentication, they use signal integrity, they use a better encryption. So if I'm doing a rogue base station in GPS and GPRS, or if I want to run, rogue base station in 3G or 4G, if the intercom is using the 3G or 4G, I'm screwed because the mobile phone will try to do the mutual authentication, and we'll see that my rogue base station is not a legit one. But to overcome to this problem, we can use downgrade attacks. To do that, we can see if we can perform some protocol attacks, but it's very difficult because we have always to the protocol attacks sometimes only focus on one specific baseband and one specific versions, and it takes a lot of time. So in general, if we don't know the baseband or the baseband version and so on, the better way is to do jamming attacks. And the jamming attack is very simple because it's just a simple Gaussian noise in targeted channels. For example, at the left, we can see that there is a GSM channel, the beginning of a GSM channel that mobile phone is supposed to see. And after the jamming, we see that this channel is flooded by a random Gaussian noise. And that means that the mobile phone doesn't see anymore the channel. That means that it cannot reach it. And if for example, this channel is a 3G channel and it's the only one, the mobile phone is supposed to fall back to 2G in a downgrade attack. And in intercoms, it's likely to be like for mobile phones, because if we found in a public documentation that if the 3G network is not reachable, the intercom will use the 2G instead. So it's good for us because if we perform a downgrade attack from 3G to 2G and create a rogue base station with a very strong signal, we are likely to trap the targeted intercom. To jam a 3G channel, we can, for example, buy a jammer in internet. You have a lot of Chinese jammer you can find on eBay and Alibaba and so on. You can, after that, disable the 2G to allow your rogue base station to transmit signal. Or you can use some tricks like I do, is to enumerate the list of URFCN close to the interceptor. After that, you translate these URFCN into central frequencies and sends Gaussian noise into each detected channels. But if you want to enumerate URFCN, people in GSM, for example, for RFCN, use the Osmocom BB, for example. But Osmocom BB, for that case, because it's 3G, for example, cannot work because Osmocom BB only works for GSM. So to do that, you can, there's a solution. You can use, for example, a node read phone that has X Gold baseband and use the provided jack interface, which is exposed, and use the X Goldman tool to to after that capture all the messages and capture the RFC messages to get the DL URFCN, which means the download the URFCN, the index, which is used for downloading. And that way, if you use that URFCN and flood with jam this channel, the mobile phone will not see the channel anymore. For other baseband, like Qualcomm, you have sometimes also other interfaces. But if you have a very new device like Samsung's have an universal method to get a list of URFCN. And to do that, you use the service mode with a special code for Samsung, for your Samsung version. And with that, you can see in logcat that the URFCN are present in logcats, like typing with ADB, the command logcat. You can see that when you are in the service mode and when you're trying to register to an operator, you will see all the URFCN that the mobile phone tried to reach. And with that, you get the list of URFCN, and you are able after that to know which channel you want to jam exactly. And to do that, let's see a little demo with a simple HackerF. So up, and test. No, it's not that. No. Okay, so I don't know if anybody can see, but here I'm calling the answer machine, and at the top and the right, you see a 3G icon, which means that I'm calling in 3G. And there is my HackerF. And with this HackerF, I used GNU Radio schema to send Gaussian noise. So the HackerF now is trying to send random Gaussian noise to some targeted channels, 3G targeted channels. And as you can see, the icon, the 3G icon, disappeared. So that means that now, when I'm calling in 2G. And as it's possible to do that, I can come with a rock base station with a stronger signal, and the mobile phone will hand over to my rock base station. So now let's set up our lab. Our lab consists of BladeRF, YetBTS software, and what I want is to trap the intercom into that rock base station, and it only costs 400 euro with all the antennas and so on. Also, let's set up our intercom using the best the documentation and all suggestion about the security. And we can see that there is 3 ways to configure an intercom, like programming the interface with the manager, with the SIM card reader and programmer, or with SMS messages. So that means that maybe if we know the number to contact, maybe it's possible to send commands to edit, to modify or add a resident number. But after that, in the documentation, it's precise that if we want to administrate the intercom with SMSs, the first admin1 number has to be set up. So our first impression is that we have, if we want to send commands to the interphone, we have to impersonate a number or find a way to bypass it. Or after that, when we can impersonate a number, we can open the door, send commands, and so on. And a good indicator when you send commands to the intercom is that you have an acknowledgement. Like, for example, if you want to write or update the number of the resident 1 with the command write a button 1 and the number of the resident to associate with, you get an acknowledgement like write a button 1. Okay, that means that the command was successful and you were able to modify or update or add a number. So our first hypothesis, let's do some hypotheses. We don't know the mobile operator. We don't know the intercom's number. The commands, for instance, can be found in public documentation or leaked documentation, or performing a firmware analysis on it. So, as an attacker, our steps are to recognize the intercom operator, to trap it, leak or guess number to impersonate, register our phone as the leaked resident number, call ourselves, and open the door. And to trap the intercom, we can brute force the four, for example, in France, the 4 MCC MNC. It takes like 5 minutes each with a strong signal. And by pushing the button in the intercom, if we see that the call was intercepted, it is a success. So when activating the GSM typing in YetBTS and seeing the message in Wireshark, we can see when pushing the button, after trapping the intercom, that's a call setup message was sent, and in this call setup message, you see a field that contains the number of the resident you were trying to call. So after that, you can associate this resident number to your IMSI, I mean your SIM card or your SIM card, and after that, you are able to open the door. What's next? If you are able to leak the admin number, you can, for example, if you can send commands, but if you cannot, you can try to find other ways, like trigger an alarm or maybe do some social engineering tricks. But if you are able to find the admin number and impersonate him, you can send commands like read, write, call 80, and two commands are very interesting because one is for updating. We already saw this command, but the other command is call 80. And why it's interesting? Because call 80 interacts directly with the baseband. So we can, for example, try to retrieve SMS messages, but I tried that with the Lincoln IDP. I get one SMS, and after that, the intercom was completely not working. So it was a little bit strange, but it works like a leader. You can also spy on building dual conversation, sending an ATS 0 equal 1 number. That means the auto answer feature, which is used for example, if I'm enabling this feature, if I'm calling the intercom, I'm able to, the intercom will ring just once, and after that, I'm able to listen the conversation of what happened around the intercom, and so on. So there's plenty of fun features in AT. And let's do some demo right now after trapping the intercom. Okay. So as you can see, there is my GSM lab here. We see the intercom. We see also here the attacker's phone. And here's the Blade ARF. So what I'm doing here, I'm trapping the intercom. After that, I'm able to intercept all the communication. So I'm pushing the button of the resident 1 exactly. And with Wireshark, I'm just reaching for the call setup message, which contains the resident number I want to leak. And with that, what I'm doing, I will associate my SIM card of the SIM card of the attacker's phone with that leaked number, with this small Python script. The Python script is communicating in telnet with YetBTS to also refresh YetBTS configuration after the modification in the configuration. And after that, And now, when I'm pushing the button, the intercom will try now not to join the legit resident, but the attacker phone. And since we just have one number, let's suppose it's the admin number, I'm able to send commands, send call AT command, and so on. But also, if I have an admin number, if I can impersonate a number, we can replace the number with a primary rate number like hello pass, optelo, and so on. So it could be an interesting thing if we want to earn money. Now, let's do some attacks with intercoms using the M2M. Intercom using M2M architecture are using cheapest SIM cards that are legit that have more than 10 years subscription. So the mobile network, the mobile operator, for example, T-Mobile or Orange and so on, for the manufacturer provides a virtual network to manage the intercoms. That means that these intercoms are connected all together in a virtual network. And also, this intercom uses the UMTS to be reachable. So we know that this intercom is managed by a centralized server. So that means that it introduces new vectors of attack. We saw already the 3G downgrade and GSM interception, but it introduced also the vulnerability that can be found while using the USIM card provided with the intercom, but also the vulnerabilities in services like web, SIPE services, and so on. So let's talk now about website vulnerabilities. In website vulnerability, we have to know that websites, the centralized server is used to manage not just one, but multiple intercom that are connected in the network, in the virtual network. And because it's web, some vulnerabilities can be found, and we can find a lot of account guessing plus brute force, authentication bypasses, SQL injections, LFI, and so on. So we tried with one product, one very used product in Paris. It's a 3G intercom that is provided with an M2MC card. And let's call it also product A, because I don't know if all the things are fixed also. But the first vulnerability was the authentication. The identification. Because product A website doesn't enforce a password to manage the intercom. That means that if I know the number of the intercom, I can manage it with that website. But also, we have to know a valid number. It's not a problem because if we try to do some animation with a very dirty script, we were able to enumerate 90 numbers in less than 3 hours on a specific prefix. And with that, we are able to manage not just one, but multiple intercom. And with that, we can earn more money than a simple intercom, for example. So that means that we can change the resident numbers to premium rates numbers for all intercom, and after that, get rich. Also, we can also open the door, but to open the door, we have to know the location. To know the location, okay, it may be hard or easy, depends if in general, if people add their home number first or in the list. And with that number, you can use a reverse lookup directory and get the address, and after that, go to the address and open the door, and after that, do what you want, plug your malicious device, and so on. Okay, we saw that. Now, speak about a virtual network as a second attack vector. We said that if we use the SIM card or USIM card, we are able to reach the virtual network, which is provided by the operator. But in product A, USIM card are protected by PIN codes. But PIN codes, you know, if you have a SIM trace, is not very good medication because you can use a SIM trace as a proxy between the SIM card and the intercom, and after that, catch the pin which is typed by the intercom with thanks to the SIM trace, get the PIN code, and after that, use the SIM card into your phone. Optionally, change your IMEI, set up the right APN. So APN also are documented for operators. If you use, for example, if the operator is Orange, you can document yourself, use the APN which is provided by Orange, and after that have a free internet connection. But if you want to find vulnerabilities in the virtual network which is provided for the intercom, you can also do some guessing, and sometimes manufacturers use their name on the APN, so you can guess with that. It's a little bit easy, but also if you enable the GPS feature and trap the intercom in your rock base station, you see that the intercom will try to join a specific APN at one time. So you can also do that tricks to have all the APN. After that, you tether the communication, use your computer, do some trace routes. After that, you can see what is on the network, scan the virtual network, search for vulnerable device, then exploit vulnerable device, hack the planet, and so on. Also, we were interested about the SIP as an attack surface because we know that Project A has a mobile application to provide video calls. But video calls, to use that application, we have to pay. Okay, we don't want to pay because we already paid for the intercom. So we try to analyze this application, and we found, okay, some very bad no SSL checks. Okay, that's cool. But the most interesting thing is that the SIP credential are hard-coded in the application. So if we use, for example, this credential, maybe we can connect to the SIP server and maybe try to call someone over intercom. So first thing, we register with this credential. We register to the SIP server, but badly, the results are not satisfying because we only are able to contact the simple user like user or root, but it's impossible for us to reach an extension, an external extension or an internal extension. We don't know why. Maybe because the number needs to be reached as premium extension. It's a kind of mystery. Maybe we have finally to take the premium option to have some more information on that. But I have a question for you, and you can answer after that. If someone knows if it's possible to find a valid extension without having to flood in SIP with invite request, it'd be very interesting. It'd be very interesting for me because I'm trying to. I want to. If it's possible, I'd be very interested. Okay. So now the part of recommendation. So with M2M network, enforce a PIN code and SIM cards like Product A, okay? Whitelist IMEIs, audit and pen test regularly the management website and the other services, restrict action on and request on APNs, firewall the virtual network and do some segmentation, audit pen test the virtual network against network attacks, monitor and also block your SIM card that have suspicious behavior, which is not the case with Product A because I was able to have a free internet access, I was able to scan, to do some nmap. So for me, it's a little suspicious behavior because in these networks, we just have to call someone or maybe send commands to the intercom. So as a conclusion, with GSM intercom, we can open a door, call primary number, spy on conversation. The intercom have the same flow as mobile phone have. Other devices also are affected by this kind of attack, not only the mobile. That's why I was saying before. And M2M and Intercom introduced new attack vector because they expose a lot of services. And also in this subject, there is a lot of things to do, and we have also further works like find a solution for the site vector problem. We have also to start attacking intercom basebands because it's also interesting subject, and also reduce our lab to a small Android with a small Android device or another alternative. But for the moment, we have a lot of work also to do on that subject. So thank you for your attention, and if you have any question, please ask. The English was.
So just line up in front of the microphones. In the meantime, for those of you who are leaving, there was a bottle concert all over the talk. If you could just take your trash with you when you leave, or if you don't have trash, just pick the one that's next to you, please. In the meantime, please go.
Sorry.
No problem.
Regarding the attack vector of downgrading the connectivity of the intercom,
Yeah.
you tried with the various radio attacks. Have you considered just using a plain attack by covering the intercom in a metal box to block all communication?
We can also, sorry.
Except your mobile?
It's possible also to cover it with a metal, like a sugar metal cover. But what we wanted to do is also to use the state-of-the-art, attacks to do that with jamming, for example.
Yeah, but it is possible to use a metal box to block the radio.
It could be possible, but I don't know exactly also the shape or how to say it. Sorry.
The material.
Le largeur.
How thick it is?
Yeah, how thick the box has to be to isolate the intercom from the network.
So there's some experimentation to do still.
Also, it's a further work.
Please leave quietly.
Yeah. I'm interested in the downgrade attack of UMTS because I was under the impression that UMTS uses CDMA, which should be pretty hard to jam with just using random noise. So my question is if you used any kind of special magic there, or did it just work away?
There's no special magic. What I'm doing is that I'm listing all the RFCN. With that list, I have the central frequency I want to jam. And what I did with the IQF is with that list, I jam like not randomly, but following the list, and for some seconds on each URFCN. But also, it's hard if the list of URFCN are large. In that case, I had only like 4 URFCN to jam. But with that list, it's possible. But if the list is very large, I admit that it'd be very hard to jam. Yeah.
So I want to ask whether the picture of an intercom in one of the web management screenshots you had, was it a picture of a product A?
Yeah, it was the picture of product A. Yeah.
Yeah, thank you.
There is one from the internet, which is the guy over there.
Mm-hmm.
Oh, okay. The internet wants to know if when you did SIP attack or enumeration,
can you repeat because I didn't hear?
Yeah. When you did the SIP enumeration,
yeah.
Did you consider using options or register or other SIP methods?
No.
Do you need 2 SDRs in order to have one jamming and the other one acting as the base station, or would you be able to do it with, say, one blade RF?
One BladeRF is not enough because if you want a stable web-based station, you want the BladeRF to do that completely. So to do jamming attack, I use the HackerRF to do that.
Cool. Okay. Thank you.
Thank you very much for your attention.